Ladies and gentlemen, class recording has started. So, first, as far as calendar goes, I updated the calendar a little bit this morning so it reflects more accurately where we are going. So I'll zoom in for you guys, but if you're watching at home, you don't get to zoom in, so sorry. Tuesday of this week, we introduced the idea of polyatomic ions. We didn't get real far on Tuesday. So yesterday, January 16th, right, we spent a good portion of the day doing names and formulas for ionic compounds of polyatomic ions. We will review that a little bit today, talk about why we review it, stuff like that. We did not get to mass mole particle conversions with compounds containing polyatomic ions. We are going to do that today. That's pretty much what today is going to be there. We will do a little bit of balancing equations, but mostly the mass mole particle stuff. Tomorrow, Friday, we get into the first part that relates back to the chemical reaction stuff that we sort of started beginning before break, and that was the quantitative relationships in chemical reactions, which is a group of stuff that we refer to as stoichiometry. It's just a fun word to say, so, and it's even more fun to do, so you know.
I bet.
Sometimes. Not really, but anyway. So we will begin on that tomorrow. That will take us through this week. No school on Monday next week, but when we come back on Tuesday, first, quiz, beginning of class on Tuesday, over the polyatomic ion stuff that we introduced this week, making formulas and names, doing some conversions, which we'll get into today. That quiz is an open note quiz, just meant to keep you up on, are we keeping up on stuff that we're supposed to be doing? I think that's like 8 points, just, you know, get real quick, okay? Katie, you asked before at the beginning of class, this Katie, sorry. On the quiz, so that quiz on Monday is a open note quiz, but on the test, at this point, I am not going to make you memorize polyatomic ions, okay? I will give you a chart that has the formula and the charges. You just need to know how to use them at this point. Like I said, when you get to chemistry, you're going to have to memorize probably a lot more of them and stuff like that. But at this point, I just want you to be able to know how to use them. Okay? After the quiz on Tuesday, we will continue on with the quantitative relationships. And then on Thursday for you guys next week, beginning of the period, we will do some more quantitative relationships, and then we will get back into lab during the second part of the block on Thursday. That lab is meant to introduce us to two concepts, limiting reactant and percent yield. We will do a follow-up for that lab on Friday of next week, so we'll go over it together and talk about why we did the things we did and walk you through some calculations. We'll go from there. Okay? Also on Friday of next week, you'll have your next quiz over the stoichiometry stuff. I think that one is 7 points. So once again, just a matter of, are you keeping up with what we're doing? Do you got the basic idea? Okay. The following week, Monday, neutralization reactions. We'll introduce you to some acids and bases. Tuesday, reaction rates. So we'll talk about why reactions happen as fast as they do and why some happen real slow. Then we are looking at tests over chemical reactions on February 1. Okay. Good there? Yes, ma'am?
How many points is the test?
I haven't made it yet, so it's going to be a little different from last year because I've done a couple of different things in some different orders, so I got to adjust that. So I have no idea at this point. All right. Good. To get us started for today, I would like you to write for me the formula for two compounds. The first compound is potassium carbonate. Oh, this is not a turn-in thing. So anywhere on the grid that we did yesterday, that might be a good place to write this, like on the bottom or something like that, because it does relate to some of the stuff that we did yesterday. Okay? Or your notes, your slides from Tuesday, wherever. This is not a turn-in thing. Okay? So I want you to write two formulas. 1, potassium carbonate. 2, barium nitrate. So, the polyatomic ions Polyatomic ions are on the chart, the grid that we did yesterday, along with their formulas and charges are there, okay? And then the elements, you should be able to get their charges off of their location on the periodic table. So let's see if we can get the formulas for these two compounds. Answers up on the board. Any question about those two? We okay? All right. Here is the much harder part. Okay. And before you freak out, okay, what I'm going to ask you to do right now is not anything I've ever asked you to do before. This is a synthesizing of some things that we did before break, some things that we did after break, all dealing with chemical reactions. So what I want you to do, and I want you to work in your two little 2-3 person groups, okay, because this is definitely something that's going to take some collaboration, okay? I want you to write for me a balanced chemical equation that shows the reaction between those two compounds. A balanced chemical equation that shows the reaction between this and this. Okay? So, what am I giving you to start with? The reactants. I'm giving you the reactants, right? From that, I want you to write a balanced chemical equation. Work in your little 2 or 3 person groups. We'll give it about a minute or two, then we'll come back and discuss. Go. As I said, this is not something I've ever asked you to do before. Okay?
We're writing it down. Wait, how do we... Sounds like one, doesn't it? Do we just write the same thing?
Yeah, none of the elements equal oxygen.
Those are your reactants. Okay? That's what you're starting with.
Wait, so potassium carbonate and barium nitrate are both reactants?
Yes, those are both reactants. So we're mixing them together. Okay?
So they're in one?
They're going to show just like you wrote there, right? Just like that's the first half of your chemical equation, right? So you have which side of your chemical equation? The reactant side. I want you to try and figure out the products.
I got you. Before. What's the other half?
That's the hard
It's the same as oxygen.
figuring out that it's that kind of reaction.
Is it a single replacement reaction? Do you think it? I got the first half of it, guys.
Yeah, good job.
Like, can you give it to me?
Don't write anything on the board yet. I'm
Just writing stuff up
working it
here.
out.
Chill out. Chill out. You're supposed to be solely focused on your sheet,
Wait,
not
I
looking
had
at
the
your
first half.
That is the first half. He gave it to me.
Hold on. I can go. Maybe later.
See if we can take one more minute.
Chill out.
Yes.
What?
said they're reacting with each other. That doesn't mean just because we mix the two of them together doesn't mean a synthesis reaction occurs. Does that make sense? The only requirement for a combustion is there has to be O2 in the reactants, right? O2 is not one of your reactants in this equation.
I seriously somehow doubt that I have this correct. So I don't know why you keep looking.
Okay. Is anybody like in mid thought process and needs like 30 more seconds, or do we want some guidance as far as where to go here? Okay. What about you guys? Are you okay over there? Do you have a possible answer? All right. So let's start. Okay. First, our two reactants in this reaction, they are both compounds, right? And more specifically, they are ionic compounds, okay? Because they contain a metal, right? Metal cation, and then even though the anion is a polyatomic, it's still like a non-metal, right? These are ionic compounds, okay? Maddie, when ionic compounds are mixed together, what kind of reaction occurs? This is a double replacement reaction, okay? So, we said double replacement reactions follow a certain pattern, right? Here's A, here's B, here's C, and here's D. Is this starting to look familiar? All right. So, what's the gist of a double replacement reaction? C ends up with B and A ends up with D. Okay? Now, here's where a lot of people fall into a trap. Okay? So, if C ends up with B, right? If we go back to these formulas that we started, right? Here's barium. Barium, based on its location on the periodic table, most of you should have done this because you all told me you got the right answers. Okay? Barium forms a +2 ion, right? Because what column is it in? Alkali earth metals, right, or column 2. Okay? Carbonate, right? CO3, but carbonate comes with a 2- charge, right? So, how many bariums do we need to balance out each carbonate? Just one apiece. So the product of this, one of the products of this reaction will be barium carbonate. Okay? The second one is the one that's a little bit trickier. What did you write as the second product?
We wrote, did I have any order?
Okay. Good. Okay. So, now, this is the way a lot of people would write it based on the formulas that we started with. Okay? But that's not the right answer. Alright? Why is this 2 in that formula? Why is that 2 subscript in this formula for potassium carbonate? Why did we have to put that 2 in that formula? Farah, go ahead. Because going back to these, right, carbonate has a -2 charge, but potassium only has a what? +1 charge, right? So to balance out the charges, I need to put this subscript, right? But now that potassium is going to go and form a compound with something else, does it take the 2 subscript with it?
No.
Okay, go ahead.
No.
No, it still has what charge to it? +1. But now it's joining together with nitrate. What's the charge on nitrate? -1. So if I'm forming a compound between potassium and nitrate, how many of each of those do they need to balance each other out? Just one apiece, right? So, Maddie, the formula here isn't this formula, right? It's just going to be what? KNO3. Does that make sense? Okay? By getting what you got further than most people. Just so you know. Okay? So, I'm not trying to say you did bad. You actually did very well. And but that subscript, right? This subscript here, right? And this subscript here, they don't go with the potassium and the nitrate. They're there to balance out charges. But when they join with each other, they don't need those subscripts. But the way it's written now, is this a balanced equation? It's not a balanced equation, right? In order to balance it out, what am I going to have to do? Coefficient here. Okay? Does that make sense? Yes, no, maybe? Okay. That's way harder than anything I'd have you do on a test. Okay? But that is something that when you get to chemistry, they would expect you to be able to do, because you know patterns of chemical reactions, you know what kind of chemical reactions occur. If you're starting with two ionic compounds, that's a double replacement reaction, blah, 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 blah. Okay? But does it make sense where it all came from? Synthesizing like a whole bunch of ideas together? Far, go ahead.
So where did, how did you know, how did you know which types form the, double, or how did you know which types of, like, atoms, like, which types of elements form in that reaction?
Because we started off with two ionic compounds, okay? It would be the same, not the same thing, but it would be similar to something like this. So if I gave you NaCl plus barium fluoride, okay? These are both ionic compounds. And if you have two ionic compounds that come together, that's like, in your mind, as you learn more and more, that's like, oh, that's a double replacement reaction, right? So that means, here's my A, right? And then here's my D, right? And then here's my C, and here's my B, right? So it followed the pattern. That's just more experience, learning, oh, that's two ionic compounds, double replacement. Okay. Please go ahead.
How do you know that CO3 has a 1 negative charge?
Okay. So, but,
Like,
go ahead.
like, how do you find that?
You can't find those. You can't figure it out just by looking at it. Okay, I mean, so you could, but not where you are at this point in time. Those are just at least those are ones that on a quiz, on a test, I'm giving those to you. Okay? I'll give you the formula, I'll give you the charge. You then have to be able to correctly apply that and go, okay, if carbonate with a -2 charge is joined together with barium with a +2 charge, then the formula would be this, because the +2 -2 balance each other out 1 for 1. Okay? Yeah, I'll give you those charges and I'll give you those formulas. Okay? Other questions? It's hard, at least for you guys, but does it all make sense kind of where it came from? Rashad, go ahead.
Why do you have to put the 2 in front of the...
Okay, good question, right? That 2, first Rashad, what do we call that 2?
coefficient.
It's a coefficient, right? Rashad, what do coefficients do? Multiply, right? But they multiply whole compounds, right? Without the 2, okay? Let me get rid of this. Okay? Without the 2, that's not a balanced equation. Because over in the reactant side, how many potassiums did you start with? 2, but over here on the product side, you only have 1, right? So I need more potassium, and again, 2 nitrates, right? But here only 1 nitrate, right? Does that make sense, or do I?
Yeah.
Okay, so yeah, we got to add this coefficient, right? We can't add the subscripts in there because that's changing the formula. That's not the formula that potassium and nitrate would form with one another, right? That's the formula for potassium nitrate, but we need more than one of them. Good? Okay, let's move on. We are going to today focus on this page right here. It was part of the packet that I gave you yesterday. Honestly, if you want to take those pages apart, feel free to do so, because they are not related to each other in any way, shape, or form. So it might be easier just to take them apart. All right. I want you guys to do 2 things for me before we start. On this page, it says chemical formulas, mass, mole, particle conversions for compounds. Up at the top, there are 12 combinations. 1 through 6 are just combinations of 2 elements. 7 through 12 are combinations of an element and a polyatomic ion. I would like you to use your periodic table and your list of polyatomic ions that we've been doing over the past couple of days to come up with the formulas for number 3 and number 5, and then number 9 and number 11. So I want you to come up with 4 formulas for me. 3 and 5, and then 9 and 11. You guys can work in your small groups if you would like to. Let's see if we can get these done in like 1 minute. Go.
Wait, do they have to be balanced?
No, they need to be balanced. This is not reaction. I just want you to come up with the formulas for the compounds that are formed between those 2. So they have to be balanced. What? The charges have to be balanced. Yes.
If it has like a 1 charge and this has a 1 charge. Oh no, this has a 2 and this has a 1. Would they switch? Like the SE would have 2 and then
After number 3 and number 5.
it's just like 10.
So Emily, those are older ones. Those are ones we've done those before. Okay. Just 2 elements, right?
I need my periodic table. Let me close my glasses. I couldn't find my thing to save my life yesterday.
Answers are up on the board. Okay, good with those 4? All right. For homework tonight, you're going to have to do the rest of them, but let's move on with what we're going to do with these formulas. Okay? Up at the top of the page, right, the title of this problem set is called Mass Mole Particle Conversions. We have done mass mole particle conversions, but we did them for elements, not compounds. When we did mass mole particle conversions with elements, we had three things that we said were equal to one another. Is this starting to sound kind of familiar, I hope? Okay. So, what were those three things we said were equal to another? Maddie, what's one thing?
6.022 times 10 to the 23rd atoms.
Is equal to what?
1 mole.
Is equal to 1 mole. Right? So we said that was true. Okay? What else did we say was true? What's one of the other two things that we said was also true? Katie, what else?
6.022 times 10 to the 23rd equals
Sorry, I should have written unit. What unit are we putting on that?
atoms.
Atoms.
Equals the average atomic mass.
Average atomic mass was the number, right? But we said that actually the unit now would be what? Not when we do this. It's grams, right? And we said that number in grams, we gave a new name. We called it what? Remember what we called that?
The molar mass?
The molar mass. Okay? And then the third thing that we said was equal to one another, right? It's kind of easy if you do these two, right? Go ahead, Maddie.
1 mole equals the molar mass.
1 mole equals the molar mass. Oop. And then, Maddie, what unit was that in?
Grams.
That's in grams. Okay. Does that all sound familiar? Okay? All right. Now that we're going to compounds,
Are you getting on that screen?
because actually this applies to stuff we've already done, not what we're going to do today.
Okay.
Okay? So, taking this, let's go here. Okay? Now that we're doing compounds, those relationships are still going to kind of be true, but we have to modify them a little bit. Is 6.022 times 10 to the 23rd atoms still equal to 1 mole? But are we dealing with atoms now? No. What are we dealing with? If compounds, what do we call one compound? A molecule, right? So, when we're dealing with compounds, 6.022 times 10 to the 23rd molecules is equal to 1 mole. Because remember, mole is a counting thing, right? It doesn't matter what we're counting, that number is still the same. Now, technically, molecule refers to a group of atoms that is held together by what kind of bonds? Covalent. When it's ionic bonds, we called them something different. Do we remember what we called them? In compounds, there was another term that we used along with that. Does that term kind of look familiar? We didn't really do it real well, but when it's a ionic compound, we call that molecule a formula unit. Same idea, just a little different name. Okay? So that's one relationship that still holds true. Okay? What else do you think is going to hold true? Any jumps in logic? Come on, honors physical science. If we go 6.022 times 10 to the 23rd formula units, and that's fun because you get to write FU on the board. I'm sure that some of you won't have any problem writing on a piece of paper you're giving to me FU. Okay? Okay? That's going to be equal to, we already got that, right? Okay? But if we make the jump here, okay, the average atomic mass, right? But now, are we dealing with the average atomic mass of just one atom? No. Now we're dealing with the average atomic mass of however many atoms are in our compound, right? It's still in grams, but we give this a new name. Now instead of the molar mass, we refer to it as the formula mass. hopefully we can make that jump, right? So, what's the last equality here? Okay? Someone besides these two? Anybody? Anybody? Okay. Please, go ahead.
The formula mass equals 1 mole.
So, the formula mass measured in what, Elise?
Grams.
Grams, is now equal to 1 mole. Does that make sense? Do you see how these relationships for compounds are similar to these relationships for elements? Yes? Okay, so, with that being said, formula mass. Sorry, has everybody got this written down? Alright. On this sheet, you'll notice down in the bottom half of the first page, it says calculate the formula mass for the compounds listed in 1 through 12. I'm not going to make you do all 12 of them, right? I'm only going to make you do these 4. Alright? So, let's talk about it. Okay? So, Nicole, how many atoms are in this compound or that formula unit, if we want to call it that way? How many atoms are in that formula unit? You tell me.
3.
Okay. I realized we were being recorded. Yeah. So, yeah. There are 3 atoms in this formula unit. Nicole, what are they?
2 potassium, 1 oxygen.
2 potassiums
1 oxygen.
and 1 oxygen. How are we going to calculate the formula mass for that compound? Well, where did the molar mass come from? The average atomic mass on the periodic table. Where do you think the formula mass is going to come from? The average atomic mass from the periodic table. Except now, instead of just one number, what are you going to do to figure out the formula mass for this compound? You're going to add them, right? But Nicole, how many potassiums are there?
There's 2.
So what are you going to have to do first before you add them together? Nope, this is already down. Okay? Multiply the formula mass, multiply the average atomic mass for potassium by 2 first, then add it to the average atomic mass for oxygen.
I can't read it.
Okay? So let's see if we can get those done for these 3 compounds. I really don't care if you get the right answer. I am careless. Except, Becca, on the quiz where there is a question that says calculate the formula mass of this compound, I would like you to show some work back. So. So up on the board, I wrote all the, that's how many atoms there are of each kind in each of those formula units. If we are a little bit off on our numbers, that's okay. We're just using different periodic tables. Yep. Are you not getting that? Actually, that's in grams. I know you want to write FU on your paper, but so, and these are in grams because these are formula masses, so they're in grams. subscripts only count for what's there directly after. Okay. Now, Kitty, if there is a situation where you have parentheses, that's different, right? Oh yeah, subscripts only count for what they're directly after. That's fine. Kitty, we may be using just the periodic table I use to calculate these may not be exactly the same as the periodic table you use. So if we're that close, that's fine. That's just a rounding thing. That's fine. I know that all of you aren't done yet, but I really want to give you the last part because it's really the important part of today. Okay? So, if you haven't written down these 4 numbers, go ahead and just write them down real quick. Okay? And then we are going to flip it over onto the back side of that page. Okay?
Wait, move.
I'm sorry. I mean, you can't calculate them on your own later. You know.
I was halfway there.
All right, so if we flip it over onto the back side of this page, I would like us to start with... Which one do I want to start with? Not that one.
Number 25.
No. All right, let's start with number 18. Okay. So here's number 18. Number 18 says, how many formula units are in 100 grams of sodium phosphate? This is a conversion problem. Alright, so how do we start conversion problems? Okay, so we start with what they gave us in the problem, right? So what are we starting with in this problem? Okay, we are going to start with 100 grams of sodium phosphate. Okay? And then if we want to, we can do what with that? We can put this over 1 if we want to, just to make it into a fraction to help us with our math a little bit later. Okay? Alright. After we write down what they give us to start with, what comes next? Einstein fraction bar. Alright? Now, whether you do it this way or not, I don't care really, but I'm going to teach you to do it this way because I think it works the best. Start with units. What unit has to go on the bottom of this conversion factor? Grams of sodium phosphate has to go on the bottom. Why? Because we're trying to get rid of grams. Nicole, what unit's going to go on the top of this conversion factor? Okay? There's our units. Once we have the units taken care of, now we fill in numbers, right? What number always goes in front of grams? Where did we always used to get that number from? What? The average atomic mass. But now, instead of the average atomic mass, what are we going to put there? The formula mass. Maddie, do you help with what the formula mass for sodium phosphate is? You just did it on the front page, unless you didn't get that far. Well, whichever one goes with sodium phosphate.
That's why I needed to copy it down, Mr. Klimzek.
Touche, Elise. Touche. Alright? So that number always goes in front of grams. What number is going to go in front of formula units? Nope, not 1. Alright. Oh, too far. Alright. There's my relationships. There they are, right? 6.022 times 10 to the 23rd goes in front of formula units. Does it matter what formula we're talking about? No. Okay. So now, math-wise, right? Cancel grams, cancel grams. Now it's just a matter of plugging it into your calculator, right? So 100 times 6.022 times 10 to the 23rd. Divide that by 163.94, and you end up with 3.673295108 times 10 to the 23rd formula units. Alright? Is that how we keep it? No, right? When we're doing sig digs on these conversion problems, what do we make our significant digits match?
Least amount of sig dig.
Always what we started with.
Well, that too.
These numbers in the conversion factor are not measurements, they're known values. 100 grams is the only measurement in this problem. So how many significant digits in our answer? 4, right? Decimal point makes all the zeros significant, right? So, 1, 2, 3, 4, right? No rounding to worry about. 3.673 times 10 to the 23rd formula units. That sheet, homework for tonight, answers are posted online. So you can check those out. Yeah, the front and the back.